Blue 42. Blue 42. Huh. Huh. He didn't buy it. I already snapped it to the guy over there. He's scoring. Alright, so today's video, domain and range of functions. Don't care about anything else really. Can you figure out what the domain and range are? And here's your first two little notes. Write it down. Domain is all your possible x values. Y is all your range values.
Domain is x, range is y.
Alright, so let's look at pictures. Yay, pretty pictures. I'm going to start off drawing a quadratic, and we're going to label the domain and range of it. So we got a nice little point there.
Okay.
And that's your quadratic. So, again, domain is your possible x values. So something about x. So when we're looking at this graph, we want to see how far left and right it goes, and are there any gaps anywhere. So we got an arrow that's angling to the left, so we're going to go left forever, so all my negatives are included. Following it, there's no gaps, another arrow, so we're going right forever. So my domain or x values could be all real numbers. That's one way we could write it. We can use brackets. So here's a note we're going to take. We can use brackets and write it like coordinates. The left limit, the right limit. So we can go from infinity to infinity, but that's actually negative infinity. I just didn't draw this good at all. So negative infinity, because we're going left forever in the negative direction. So this is one way we could write it. They could say all reals, because all numbers are included in this function for the x value, or the domain. So Ramsey over here, let him do the other.
So now we're talking about range. Range is the y values. So again, we'll look at our graph. We'll find out where it starts at, in the y values. Obviously, we don't have nothing over here down here in the negatives. But looking at my graph, looks like we start right here at positive 1. Follow my graph to the left. There's no gaps. We get to an arrow. Arrow means it just keeps going on and on and on to infinity. Start here at 1 again. Go to our right. Get to the arrow. There's no gaps. That means it just keeps going on and on to positive infinity. So our range, our y values, are all numbers that are greater than or equal to. It's important to have that little bar, little line underneath your sign, because that means that value is included. So your range is all values greater than or equal to positive 1. Right, that's our range. Let's do another one. You want to add anything?
Well, how do we write it with the bracket thing?
We'll do brackets.
Those are weird.
So we know that we're going to use a bracket because 1, the number positive 1, is included, right? Bracket means it's included. And it goes to, like we already said, positive infinity. We use a bracket again, right? So in our y values, these are our y values, from 1 to positive infinity is going to be included in this graph.
Let's change it up to blue. Now we'll do another quadratic. This time we'll throw in a little curveball there.
Ooh. And it's going down.
Alright. I'm going to do range this time, just to be different. I'm going to do the range. So I got the range.
So he's starting with our range.
So that's my y values. So when I think range, I'm thinking how far up and down it goes. So here's a high point. So I'm not going to have anything above that. So this is at
maximum
2. So my range is going to be, there's no gaps. Oh, and it goes down forever. So from here, down forever. So my range could be all numbers less than, since it's open, it's not going to be equal to, so just less than 2. Or if we're using the brackets and parentheses, we would write it as positive 2 all the way to negative infinity, because we're going down forever. Now, negative infinity is included with it. Now remember here, it's not included, it's not equal to. So that's when I use a parentheses instead of a bracket.
Again, it does matter whether you use a parentheses or a bracket. Bracket means it's included. Parentheses means that number is not included.
Okay, so there's your range. Let Coach Ramsey here take over with the domain.
Domain. Right, so domain, we're talking about x values, right? Our inputs. So let's look at our graph. We know we have some arrows here. So starting over here on the left side, arrow means it keeps going on and on. So from negative infinity, and then we get to our graph, we're going, we got a gap, right? That gap on the x value is at -2. So there's not an x value for -2, right? So we know that, and then we keep going, no gaps, until we get to the arrow. So then that keeps going on to positive infinity. So to show that, I'll start with our brackets and parentheses. Negative infinity, we said was included, right? Negative infinity. And then it goes to, boom, a -2 on our x value. There's a gap, right? And it's not included, but we're going to show that here. That's a parentheses, right? -2 because it is not included, right? Then we're going to pick back up at -2. So here we go, parentheses, -2, and it goes to positive infinity with a bracket, right? So again, we've got kind of two different parts here because it starts at negative infinity, it's included, goes to -2, there's a gap, so that means that parentheses, it's not included. Then we kind of pick back up to show the rest of our domain, starting at -2 all the way to positive infinity. Another way we could say this, right? Also our domain could be all numbers except -2 for our x values. Again, domain is our x values. So you could write, you could see it like this, all numbers except -2. There's also another symbol if you want to write it looks like this, meaning not -2. You can see several different ways it's going to be written. But again, this is our domain.
Alright, awesome. So there's two examples of quadratic graphs. We'll deal with those more in future lessons. So now let's look at something linear. So let's see. We got this going through here. Linear is fairly simple if they don't put gaps in it. So I'll just do both of these this time. Domain, well, going left forever, so all these are included because domains are x, left and right. I don't see any gaps. We're going that way forever and this way forever. So you could say again all reals, or they might use the brackets and parentheses from negative infinity, which is included, all the way to positive infinity. So now with your range, no gaps, it's going up and down again forever, so it's pretty much the same thing. So your range is also going from negative infinity all the way up to infinity. And that's a linear with no gaps. You want to try another linear?
You want to show one with gaps this time?
Yeah, we can do that. Let's see. Do something crazy. There we go.
Okay, so again, we have another linear function, right? Just by looking at this graph, we see an open circle here, so that's a gap. We see a solid circle here, a solid dot, solid point. So maybe we're like, oh, okay, so what does that mean? But I also see two arrows, right? So if I want to start with my domain, again, domain is my x values, right? I'll start by using parentheses and brackets. So domain x values, we see an arrow here, so we know that just keeps going on and on to infinity, right? So negative infinity. Now we're going to be moving to the right, or moving towards positive values, right? I'm going on my graph. Okay, so there's a gap. That gap is at 0 of my x values, right? On the graph here. So I know that 0, there's a gap. So it's not included, right? So that means I've got my parentheses. Y'all with me? So now I'm going to pick back up at 0. Again, it's not included because there's a graph. And then it keeps going and going, no more gaps. I'll have an arrow here, so I know that keeps going on to positive, bracket, positive infinity. And that positive infinity is included, right? If I wanted to go ahead and just show my range, again, range is our y values, right? I'll stick to this format here. Obviously, y meaning up and down. So we're starting down here, we're coming up, we got the arrow, so we know that keeps on going down and down and down and down. So our range, right, it's included negative infinity to, we're getting back to our linear graph, we're here, boom, we got a gap. That gap is at -2, all right, and it's on the y-axis. So we know at -2, we don't have range. There we go. At -2. Now we got to pick back up, right? Because we definitely have more values here. So starting at -2, we're going up and up and up. Now we do have this dot here, but again, it's filled in, so don't let that confuse you. That exact point is included, right, for domain and range. Then we get to our arrow, so it keeps on going and going, all the way to positive infinity, and we show a bracket, right? So this is our domain and range, kind of in our bracket parentheses format.
Look, what? Good job. Alright, so now we're going to mix it up a little bit. We're going to introduce some exponential function, just one of these, and kind of explain what it does. So it's going to be a little different.
Whoa.
Alright, so I'm not putting any gaps in this one. This is an exponential function. They grow exponentially or decay exponentially or go down. It's pretty much you're multiplying by something. And it's kind of like a video going viral. So, yeah. We have this, and then it's just multiplying. And you can see it's just going to continue to go up forever. There's not any gaps in this one. And then it's going to come down. It shrinks, it shrinks, it shrinks, it shrinks. Does it ever hit 0, though, is the question. That's what we're unsure about. Is this going to keep going down forever? Because it looks like it's getting level, and it's not really touching 0. So we'll think of it this way before we discuss it. So let's pretend it's doubling. I know I didn't draw it correctly. So it's 2 to the x power. So we're always doubling. We had 2, or had 1, then we had 2, then we had 4, etc. So let's think backwards. We got $2, and we cut it in half. We have $1. Then we have 50 cents, quarter, 12.5, 6, and then we get to the penny. So right here we're at a penny. And then can you have half a penny? Yeah. Then you have half of that half, then half of that. Do we ever have 0, though, if we keep cutting something up? If I just keep cutting into smaller pieces, will it ever be nothing? No. It'll be something that we don't care it's so tiny, but it's still something. So this graph is going to get really close to 0, but never touch it. Never. So the domain is left and right. Well, it's going left forever, it's going right forever. So it's like some of the previous, it's all real, or negative infinity, the positive infinity included. But the range, again, we're not going to touch 0. So we're getting smaller, but we never touch 0. So we're going to have y is greater than 0, but doesn't include it. And then you'll see as we go up forever, it's always greater than that. So we could say, with our parentheses, 0, and positive infinity with the bracket. And this is just an exponential one. We will go over these more in detail in a future lesson. And now we're going to get to the weird stuff called piecewise.
Piecewise.
Or just something weird. I'm just going to draw something weird right now and let Ramsey deal with it. How about that? Yeah. Strap up. Here we go. So I'm going to have an arrow that way. I'm going to go wee, wee, wee all the way to here. Make it up. No, I don't want to do that. It's too easy on him. We're going to go wee here. Close it. I'm going to go here, back down, And here, forever and ever up, I'm going to put an open circle right there only. Right there is an open circle. And we're going to see if he's got it.
All right, so we got this weird looking graph that Coach Greg has drawn for us. You know, he really is an artist. You should check out some of his work. But let's look at it. Let's find the domain and the range, right? Remember, domain is our x values, range is our y values. You know, I know there's a bunch of humps and twists and turns in this, but I don't really care about all that. I just care about where my arrows, I got 2 arrows, and where I have some open circles, maybe a closed circle that might throw us off a little bit, but I think we can figure it out.
I made it not function. I made it kind of overlap. I didn't make it a true function.
Yeah.
Somebody might judge me.
Yeah, now it's definitely. Sometimes our pictures aren't drawn to scale. Just keep that in mind. So let's look at our domain first. We'll start with our x value. I'll go here. So again, domain, that's our x values. Can't forget that. So let's look here on our x-axis. You know, if I'm following this graph, I see a parenthesis, or not parenthesis, an arrow, and it just keeps going on and on and on. So I know that my input, or my x values, my domain, I'm using several different terms, is negative infinity, and it's included, right? So now we're going to work this way. I'm not seeing any gaps, It is still a function. Here, now I'm going back up. Boom, 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 boom. Found the gap, right? That gap is at 1, 2, 3, 4 on the x-axis, right? So I know at 4, that value is not included in our domain. Right? So I'm going to use a parenthesis. Now I'm going to pick back up at 4, right? So I'm going to keep it going here. 4 is not included. Follow the rest of my graph. I get to an arrow, so I know I'm good. That keeps going on and on and on. So my x values keep going on and on and on. To positive infinity, it's included, so I use a bracket. So there's my domain kind of in parentheses, bracket form, right? Now I'll find our range. Let's see, I'll go range, I'll do it down here. You guys can still see, yeah. So range, again, that's our y values, can't forget. So let's look. Where is our lowest point so that we know where to start on our range? Or is there a lowest point? Maybe it keeps going on to negative infinity. Let's look. Boom. Right? My graph is, kind of starting right here in terms of y values. And that value is at negative 1, 2, 3. Negative 3. That value is included. Right? There's a point there. It's a solid circle. So it is included. So at negative 3 is kind of where my values start. If I want to show you guys in the bracket form. Negative 3 is included. And then let's just go ahead and start to the left. It keeps going on and on. So, I'm good there. That's going up. But is it the same for the, if we go to the right? We got to be careful here. This could be a curveball. We can't swing and miss. So we're going up. We go back down, but, we're still going up. Okay, we got a gap. Right? So right here at 1, we have a gap. But let's think about it. I don't have a gap here. You see what I'm saying? So the value 1 of our y's is actually included. Just because there's a gap right here, if you look over here on this part of the function, there is, a point. I could even draw one if I wanted to. There is an included value at that exact number right here at 1. Right? So we're good. It just keeps going on and on and on. We get the 2 arrows. Boom. So that's all the way to positive infinity. And that is included. Right? So this is kind of bracket form. I could say that my range is all values greater than or equal to, again, that's negative 1, 2, 3, negative 3. So this, again, is my range.
All right. I think it's stumping you. We'll just throw one more curveball at y'all and see how you do. Yeah, here we go. We'll do that there. We'll go to here. Color it that way. Here we go. Oh, bam! I'm going up here with an open one again. And I'm going to go down curve. Yep, here we go. Yeah, buddy. Color it in. I'm going to go way down here. Just put an open dot. just for no reason. And then we'll go that way forever. Whoa, that is weird. Alright, so this one is definitely different. I might throw in an extra part. Probably ought to, but I'm not going to. Alright, so I'll do this one because I created this monster. So domain, so my x value is left to right. So I'm going to start at here. So I'm at 1, 2, 3, 4, 5. Negative 5, that's where I'm starting. So at negative 5, it's not included, so it's parentheses. And I'm going all the way to here, up, then I stop. Then I put an open one, so I can start here, keep going, bam, that's good. But directly below it's another open one, so I can continue on that line. So there's no gaps between here and infinity. I just jumped. So I stopped here, then I started again up there. So we're going to positive infinity, and it'll be included. We haven't done anything like that, so it's a lot of jumping around. So there's your domain. Now the range, I might have made this complicated. So let's look at the range. I'm going to start at the top and work my way down. So we're up here at 1, 2, 3, 4, 5, positive 5. So with my range, we're at a positive 5. And we're going down. 5's included. Kind of working backwards. So if we get all the way to here, well, is there a line I can jump on and keep going down from here? Yeah, so I can start there and go all the way to negative 1 and stop. And negative 1's included, so from there to there. And then I have like a huge gap from negative 1 to negative 3, where none of these are included, and then at negative 3, it's going horizontally, so it's only negative 3. So it'd be these and negative 3. And a negative 3. I don't know if I've ever seen one like this.
Well, you have now.
But yeah, there you go. So there's domain and range from graphs. Hopefully it's useful. Now we're going to hit up some other things like the tables, because they're really hard.
Ooh.
Because these are rough. This is like the hardest thing in the world. So if you wrote it down, that first thing, it said domain is X.
X.
Oh wait, it ain't that hard because it's literally the X values. So here the domain is 1, 2, 3, 4, 5. They didn't tell me anymore, so there's not any more. That's it. 1, 2, 3, 4, 5. Now range, on the other hand, might be tricky.
Yeah, this one's a little tougher. You see, range is, well, we know it's Y. Oh, and it's really, literally just the rest of the Y values here. 22, 24, 33, 21, 77. That's it. We don't know. They didn't give us anything else. So we know that our domain is our X values, 1, 2, 3, 4, 5. Our Y is, in this case, profit, 22, 24, 33, 21, 77. Right? Those are our Y values. That is our range.
Tables be easy. Alright. Now the word problem. So go ahead and read that. Let your eyes cross. Now we're going to go over this one. And then the next 2 slides you can try, and then we're just going to put the answers. So pay close attention to this part of the video. What is the range?
Range is what? Range is what?
Yeah, you said it. Output. Y values. Okay. So another name for range is the output when we plug something in. So the range of this particular function. So we're going to deal with this function, x squared minus 40. We want the outputs for this function, the y value, the range, when the domain is. So now they're about to tell us what to plug in.
Domain is the X values.
Oh, they're using other words. I don't like these. Defined as the set of integers. So what's an integer? An integer is just a positive, negative whole number. Okay? So integers are positive and negative whole numbers. X, I don't know what they are. Integers X such that negative 7 to negative 2. So X has got to be bigger than negative 7, but can include it. So I'm going to use negative 7 for an input. going to make like a table, and I can go all the way to -2. So -6, -5, -4, -3, and including -2. So if these are my inputs, I want to take each number, plug it into the function, do some math, get the output or the range value. So -7 squared. If you type that in a calculator without parentheses, it's going to mess you up. Because your calculator is going to square the 7, then put the negative. This means -7 times -7. So that's 49. 49 minus 40 is 9. So then we just keep doing that. So now we put a -6 in there and square it. 36 minus 40 is -4. Now I'm going to go ahead and eliminate some answers because I got a few. That's got a +9 and a -4. That don't have either one of them. That wrong. That has a -4, but there's no -9. So I'm done. I don't need to do any more. This has got to be my right answer, but I'm going to go ahead and fill in the table anyway. Plug in 5, 25, that is a -15. Plug in your 4, 16 from that, it's -24. And if you keep going, you'll see we have all these values, -31 and -36.
Again, guys, just to add something, when you guys are looking at your EOC tests or your ACT tests, those are, there's time, they're timed, right? You have to solve questions in a certain amount of time. So in this particular example, I'm all for checking yourself, making sure you're right. But if you were able to eliminate the other two answers and you got to where you're matching up, you know that C is the answer. So if you want to save, 30, 45 seconds, which could matter when you start taking ACT, something like that, just keep that in mind. Right? It's okay to trust yourself.
I reckon that's good explanations and stuff. All right, here you go. Do it. I dare you.
Give it a try.
But hit pause so you have time. Alright, so you got tricked. I'm just going to tell you, you got tricked. No, I ain't playing. Flag on the play, I'm rude today. So, is 10 included? No. So if you put 10 in there and said 10 times 2 then plus 5 is 25, you got tricked. You burnt. 25 does not count. So this answer is wrong. So hopefully you didn't put A, but I know you did. So I'm going to start with 11. Change that to 11. 22 plus 5 is 27. Oh, none of those have that. Done. One more. It's not as tricky. Or is it?
Give it a try. Pause.
All right, do yours.
All right, I think that was enough time. What is the range of the function h of p equals 5p minus 10 when the domain is defined as a set of integers such that greater than -2 and less than 3? So let's just pick some. You want us to just plug in values, or are we supposed to just write the answer?
Yeah, let's just write the answer. I've tricked them enough. I'm curious if they got them. All right. Plug in -2 or do a.
Is it included?
No. So we got to start with -1 and go all the way to 3. It's not included. It's all the way to 2. And where they said integers, that's my clue that I have to use whole numbers on them. Positive or negative between there. So -5. So we got a -15 for a range. Plug in 0. We got a -10. If you know your slope up there, we're going up by 5. So next will be -5. And then the last one, 0. So this should be your solutions to this problem. So the range for that function at this interval between these two sets of numbers is those 4. All right, now you're getting closer ready to the test. And this is an abstract question. We're going to drag and drop the solutions. This is what I'm going to tell you. You've got to drag one of these two into the correct spot. Each value of blank in the domain generates only one value of blank, same size blank, but they're different sizes. I don't know about the time. I guess, period. So is this the x or is this the x? Which would represent the input or the range? I mean the domain, input or domain? Yep, it should be t. V of t is the y value. And it comes back to how they write it. Normally we write it y equals mx plus b or something like that. Y equals. If I was writing in function form, it'd be v of t equals. See how that's in the same place as the y? And the only thing I give you as a clue to x and y to tell the difference is that word. Domain. It's x. So it's a lot of memorizing what domain means. It's the x values. Okay, try this one on your own. Okay, you're done. We'll explain it. Alright, a function, not telling you what it is, has a domain or x values of that, so between 0 and 20, and a range between that and that. So what I'm trying to show you here is kind of building off the last slide.
Select all false statements.
So we want the ones that are, whoa, I need to change my buttons, that are false. So one of these is x, one of these y. Well, remember, v of t represents the y, and over here is the x. So in this case, it's a little different. The v is there, but the t is changed, right? The t is changed to a number. So, in function form, this is the x and this is the y. This is the x, this is the y. So if they write it like this, x, y, input, output. And we talk about that in the evaluating function section. I'm just throwing it in here because we're talking about domain and range. Just another way they can tie that together. So we're just matching here. Now that you know these are x's and these are y's. So figure out which ones fall in those intervals. So x is 11. Is that up there? Okay, is 0 between -10 and 8. Okay, that's a true answer. We don't want that. -5 is not between 0 and 20, so that's a solution. 6 is 22 for x. Too big. So that's a false statement. 10 is between, 0 is between, so that's a true statement. 1 and 1. 1 is between that, 1 is between that. 20 and 20. 20 not included?
Not included.
So this is going to be a false statement. And 3 is between that up there and 9. Is 9 between these two numbers? No. So that's another false statement. These are like my favoriteest questions ever.
Get used to these select all that apply questions. There's your foreshadowing.
Bam. Oh, I didn't hit the button. That's a curve. Alright. New type of question. We'll give you 2 more examples after we explain this one. Read it. It's wordy. Okay, you read it. Which of the following values is in the domain? So domain's x, and it determines the output. The cost of games in dollars is a function of the number of games bought. When it says a function of, that's their code for saying this is the x values. This determines the output. So the number of games you buy determines the cost that you pay. So which one of these numbers could be part of the domain? So each game sells for $20. Is that domain? No. That's the y values. They're going to be 20, 40, 60. They're going to be multiples of 20. A video game company has a total of 2,000 games. So now that's the most. So now we just look at these and think. Can I have 40,000 games?
I don't think they have 40,000 copies.
We only got 2,000, so that's not in there.
Nope.
Can we have 50.5 copies of a game?
If you break a game in half, it ain't going to play too good. So
in this way, this is a concrete thing. Bam, it's got to be bam, just whole numbers, whole thing. So no. -10. Could I have -10 copies? No. Is 999 part of that 2,000? Yes. There's your answer. Bloop, 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 bloop. Pause. Begin. Alright, so again, domain. We'll let Coach Ramsey discuss this.
Oh, I have to read it first. I haven't read it.
Guys, it's domain again. And I threw in 3 numbers because I'm just tricky like that. It's a function of the number of packages bought.
Domain.
The number of packages bought.
So we're looking for which of the value is the domain, right? So each package of buns contains 6 buns and sells for $2.50. The cost of the buns in dollars is a function of the number of packages bought. So which value is in the domain of the function? So negative 250. Can you have, negative packages of buns? Right? No, you can't. So we're not, that one's out. Kind of the same thing here. Can you have half a package of buns? Well, you can, but if you go to the store and chop a package in half and then take it to checkout, they're not going to be too happy with you. So again, concrete, you can't have half a package, right? So now 8. Can you sell 8? Well, it says it has a total of 12 packages. So, 8, yeah, that's in the interval between, none and 12. And then 20, we only have 12 packages. So we can't sell 20, we only have 12, right? So our value that is included in the domain of the function would be 8. We could sell 8 for $2.50 a package, right?
Awesome job. Oh, that's complicated. We'll come back at it in a second. You've done one like this a minute ago, so here's your chance to do it again. I'm just going to mark the answers, all that are false. Is that it? That looks to be it. 2 false answers. That's between there. 2 is over there. Alright. So you are packing candles in boxes. Alright. You got your box. He's over there putting these candles in it. And he can fit 20 in each box. So write an equation in function form that represents the number of candles you can pack into X boxes. So right there, X is the domain. So when we're writing the function, we'll have X for the domain. And the other half is the number 100 in the range. So I'm going to let Coach Ramsey write the function over there because we should be pretty good at it. And I'm going to make a table of values here for it.
So we're going to use C of X. We're using C of X because it's candles in X boxes, right? And you can fit 20 candles into one box. So that would be just 20X, right? So this is the function we're going to use to plug in our X values, our domain, our inputs, to find our Y values, our outputs. Boxes to candles.
I got 0 boxes. I got no candles. I'm not going to smell good. But I got 1 box. I should have 1 times 20 candles. If I get a second box, I'm going to have 40. So this part B is saying, is the number 100 in the range? So that's the candles. So in this column here, am I ever going to have 100? Well, if I do 3, I'm going to have 60. If we keep going, eventually we will. We'll say yes. But it says explain. So how can I prove it that there's 100? Well, when I have 5 boxes, with 20 candles each, we're going to have 100 total candles. So that's just my explanation. At 5 boxes with 20 candles each, we're going to have 100 total.
5 times 20 is 100.
And the candles are the range. So it's a little bit of an understanding of that. So there's your word problem with domain and range a little bit. Now to our final graph. What I want you to do here is select all the true statements. So we want you to select the true statements. This is kind of like your final quiz with the graphs.
You can do it.
I'll let Coach Ramsey answer the red ones. I'll get the green ones. We'll highlight it if it is correct. If it is true, we will put our line through it.
So Greg's going to start off with the top.
So from -1 included all the way to 3 for my y values. That's my range. So I'm going from -1 all the way up to +3. So at -1 I'm included. Good. No gaps. I can jump here and keep going. And I made it all the way to 3. So that is a correct answer. That is true.
All right, so for letter B, we're looking at, be careful here, we're looking for x, right? We're looking at our domain values. So at -1, and we're saying it's included, it's going to be greater than. So -1, I definitely have, a solid part of the graph. So I'm good. So now I'm going up, right? I got a gap here, but I got a solid dot here. So I'm good. Going up still. And then at 1, oh, we got a gap. But if I go over here, I'm good. So I'm still going up. Boom. There is at +2. Sorry, I'm at y. Hold on. We're at -1, going to 2. We're good. We're good. We're good. Look here, though. From 1 to 2, right, I've got a gap here. So this would not be true. From 1 to 2, there's nothing. If I'm looking at my x-axis and going down here, nothing. So B is not true.
Bad. B's bad. We got this. Next one. From 1 to 3. Not just from -1 to 3. Well, isn't this interval included in that one? Yeah. So I'm not going to waste my time because I know this is true.
It's inside letter A.
Yeah.
Okay, back to letter D. We're looking at domain, x values again. So starting at -3, and we're saying it's included, so -1, -2, -3. Well, I've got an open circle here, so that means it's not included. If I go downwards and upwards, there's no other parts of any of the graphs. So I can go ahead and stop there. I know that's not true because -3, is not included. Letter D is saying it is. So no, bad one. Not D. And then if I look at letter E, right? So we're looking at x again, so that is the domain. It says that at +2 it's included. So +1, +2 on my x value. We go down, there's definitely an included point. It's a solid circle. Okay, so I'm going to keep going to 3. Well, that one was pretty simple, right? Because from here to here, there's definitely parts of the graph. So that is true. Highlighted, good. So that is true.
And I got the last one. Y is greater than or equal to -3. So Y is my range. So 1, 2, 3, so -3. And I'm going to just try to go up from here and see if I got any gaps. So going up, nothing. And jump here, keep going up. And jump to that one and keep going up. But you stopped. This says greater than or equal to -3. Since it's just greater than, that means it's got to keep going up forever. Well, we clearly stopped right here. There's no continuation, so this one is a no. So there you go. We've introduced domain and range, showed some various functions. Arrivederci. Jinx, it didn't stop. Au revoir.